All right, so all of you have this on Canvas, this filled in note section, but for those of you that were gone, I wanted to give a little video to explain some of it on graphing tangent and cotangent. So tangent, cotangent are periodic functions, just like sine and cosine. They have a period of pi over k and not 2 pi over k. So that's one thing that's different. So normally sine and cosine are one full period is 2 pi. It's one time around the circle. But for tangent, cotangent, it's just pi, which is halfway around the circle. And the reason why that is recall that tangent is y over x. So this means that it's undefined when x equals 0 because the denominator cannot equal 0. Okay, so sine and cosine are never undefined because sine is just y, cosine is just x. There's never going to be a denominator that's 0. So tangent and cotangent are a little unique like that. So if we look at our circle, okay, pi over 2 is straight up, and then negative pi over 2 is going down that direction. So this is where tangent is undefined, because if we actually find the tangent of that spot, if y is 1 and x is 0, and then down at negative pi over 2, the tangent's negative 1 over 0. So both of these are undefined because the denominator is 0. So the tangent is undefined at pi over 2 and negative pi over 2. And the period runs from negative pi over 2 to pi over 2. Okay, we're going to talk about how we're going to graph that in a second. So we filled this table in over here by using the points on here, right? So this is pi over 4, this is pi over 3, and then we have pi over 2. So using those points, okay, the tangent of 0 is 0 because it's 0 over 1. The tangent of pi over 4 is 1 because at pi over 4, if you look at your unit circle, it's going to be square root 2 over 2 over square root 2 over 2. So we talked in class about that. Since it's the same thing in the numerator and denominator, it's going to be 1. Okay, the tangent of pi over 3 is going to be square root 3 over 2 all over 1/2, which ends up being square root of 3, which is 1.73. Okay, at pi over 2, it's undefined. At negative pi over 4, it's negative 1 because it's just in the lower quadrant in quadrant 4, so it makes the 1 negative. And negative pi over 3 is negative square root 3. So again, it's negative. And negative pi over 2 is undefined. So really for tangent, we're looking at this part of our graph. We're going up to pi over 2, and we're going down to negative pi over 2. And then the values we get at pi over 4 and negative pi over 4 are the same. They're both 1. Just one is positive, one is negative. So that's where those points come from. Okay, so at pi over 2 and negative pi over 2, we have vertical asymptotes. So we got some asymptotes, which means our graph is going to approach them, and it's going to go to infinity or negative infinity. So right here, if we approach pi over 2 from the left, remember that this negative symbol means approaching pi over 2 from the left. And then if we approach negative pi over 2 with a plus sign there, that means we're approaching it from the right. So when we graph it using the stuff from the table above, 0, 0, pi over 4 is now one box. So pi over 4 is at 1. Negative pi over 4 is negative 1. And if we did pi over 3, 1.73, and negative pi over 3 be at negative 1.73. And then we can see the asymptotes. We have asymptotes at pi over 2. And we have asymptotes at negative pi over 2. So our graph approaches infinity as it goes to pi over 2. It approaches negative infinity as it goes to negative pi over 2. Okay, and if we wanted to graph it again, like graph more of it, the next asymptote, you see the asymptotes are 4 boxes apart. We just go 4 boxes over and draw another asymptote. And then we just move these points 4 boxes to the right. So here, here, and here. So you see those green points there are 4 boxes to the right. Then we have like our decimal too, like right about here and here. Okay, and we could just continuously draw this over and over again. It's just like sine and cosine. It repeats over and over and over again. Okay. And cotangent, same thing, but now remember that cotangent is x over y. It's undefined when y equals 0, so when the denominator is 0. Okay, and this time cotangent is undefined at 0 and at pi. Because if I just quick explain that, if you think of your circle, over here at 0, it's 1, 0, so y is 0. And then over here at pi, pi is on the left, it's -1, 0. So again, your y value is 0. So it's undefined at 0 and pi. Okay, we filled our table in. So it's undefined at 0. You can see it's undefined at pi. At pi over 2, which would be straight up above on our unit circle, that's going to be 0 because x is 0, y is 1, so it's 0 over 1. And then we have these points in between there, and again, these are just, we took the x over y for each of these. Okay, so at pi over 4, it's x over y is 1. At 3 pi over 4, x over y is -1, and we found those points in between there. Okay, and then on our graph, we have asymptotes at 0. We have asymptotes at pi. And then again at 2 pi. And we have asymptotes at every version of pi. So pi, 2 pi, 3 pi, 4 pi, and so on. And then if we sketch these points from here, the points would be, you can see them on the graph there. Pi over 4 is at 1. 3 pi over 4 is at -1. And then this is kind of the inverse of the tangent. So tangent went up to the right, down to the left. Cotangent goes down to the right, up to the left. And then again, this would just repeat over and over and over again. Okay, so the next part it says, the complete graphs of tangent, cotangent are as follows. If you want to graph a quick sketch, tangent is undefined wherever x is 0. So x is 0 at pi over 2 and -pi over 2. So that's why we have the asymptotes at pi over 2 and -pi over 2. Okay, and this is just a quick sketch. We know that tangent goes up to the right, down to the left, and then it's going to be, these points in the middle are going to be 0. So it's a quick sketch of the graph. Okay, and I'm going kind of quick, but just pause if you need to. Cotangent is undefined at 0 and pi, so that means we have asymptotes at 0 and pi and -pi. If we kept going, it'd be -2 pi, -3 pi, and so on. And then again, we have the points at 0. And I know I didn't put other points on here, but we know the general shape. Cotangent goes up to the left and down to the right. And you can see that we graphed 3 full graphs of it. So like we have half a graph here, 2 full graphs in the middle, and then half a graph on the right. So just sketching it, just kind of getting the general shape. Okay, lastly, we can shift these things. So tangent and cotangent have equations similar to sine and cosine, but just recall that the period is pi over k, not 2 pi over k, and it has an amplitude, or it doesn't have an amplitude, but it still has an a value. It stretches it. The reason why it's not amplitude is just because pi and cosine and sine look like that, but tangent, cotangent go on to infinity. So you can see in this graph, our a value is -2, our k value is 1. So what this means is you take your parent graph is in pencil there. I'll make the parent graph in blue. So you take every y value. So you're taking y times -2. So if you look at this, if we take this y value, it's -1. -1 times -2 is +1, +2. If you take this y value, the y value is 1, times -2, flips it down here. 0 is still 0, so that's where we get this orange graph. So it reflects it. And once you have these points, now all you have to do is go over 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the right. And that's where I got this other graph from on the right. And we can also go 4 to the left, and this just repeats over and over and over again. So we took our blue parent graph from the screen and just took all the y values times -2. Okay, down here, we have k is 2 and b is pi over 4. So since k is 2, if we take pi over k, we get pi over 2 for our period, and that is half as wide. So everything's half as wide as it was before. And then we have to go to the right. It's 1 box because I made it 4 boxes to pi in my graph. So if you look, the pencil is the original graph. So if I make the original one in green, like let's say here's our graph for tangent. Tangent is undefined at pi over 2 and negative pi over 2. We have to shift that in half. So if we're looking at this one right here, if the asymptote's half as wide, we go to 1, and then you have to go 1 box to the right. So that's where the new asymptote is. I'm going to make that in red. If we look at this other green asymptote, if we go half as wide, that puts us at -1 box, and then you have to go to the right 1 box, because pi over 4 to the right means the right 1 box. So here's our new asymptote. To get our graph, we're looking here. If you go half as wide, that puts you at 1/2, and then you have to go 1 box over to the right. That's how we got that point on the orange dot. And then if you look at 0 on our parent graph, half of 0 is 0, and then 1 box to the right. Look at this point at -1, -1 box. If you go half as wide, it's right here, and then go 1 box to the right, that puts you over here. So that's how we got this line right here. And then we just duplicated it over and over and over again to get what we have there. All right. Try to be short and sweet. Hopefully that helps.